My name is Philip Chimento. Welcome to my pre-recorded talk about JavaScript in GNOME, types, and more types. I am the maintainer of GJS, GNOME's JavaScript engine that powers GNOME Shell and all of your GNOME Shell extensions and many of your favorite apps. In my day job, I work as a JavaScript standards engineer at Igalia. So most years at GUADEC, I give an update on what's new and what's coming down the line for GNOME contributors who develop in JavaScript. And I also like to pick out a couple of topics to highlight that are on my mind. So in this year, it'll be static analysis and the big hammer. The slide deck is also meant to be a resource that you can consult later. And the slides are already available on my web space. So if you want to click on the links now, you can go to this link and follow along with the presentation. So what is new for GNOME 50 and the upcoming GNOME 51? This part of the talk, I'm primarily aiming it at people who write code for the GNOME platform in the JavaScript programming language, whether that's GNOME Shell or apps or shell extensions or even command line scripts. GNOME has its own JavaScript engine for all of these purposes, GJS, which is an extended version of the JavaScript engine from Firefox, the browser. In past years, I've given talks with extensively long sections about what JavaScript language features are new and how to modernize your code to take advantage of them when we upgrade the underlying JavaScript engine to one from a newer Firefox. But there is actually no code modernization to do in these two release cycles because we're not getting a new JavaScript engine this time. Firefox's release cycle doesn't quite line up with GNOME's, and this year the release date of Firefox 153, which is the next version we're upgrading to, happened to fall a couple of weeks after GNOME's API freeze. In fact, it releases next Tuesday. But we are still getting some new stuff implemented by our own contributors. Here's a screen full of C functions that used to be not available in JavaScript or not work properly, but we've merged better introspection support for them. There's the timer once functions, some Cairo functions, some convenience functions for around GTK keyboard shortcuts, and better support for unions. There's also this cool new JavaScript-friendly convenience API for GTK Builder. You can pass in objects and functions, and they automatically get hooked up to your builder file. And you can also destructure them when you get objects from the builder. And this just makes GTK Builder a lot more pleasant to use than it was. So not for GNOME 51, but we also have some exciting contributions from our Google Summer of Code intern coming up for GNOME 52. Many of you have probably run into Angelo before. Angelo this year is working on implementing the debug adapter protocol in GJS. You might have heard of this as the V8 debugging protocol. That was an earlier prototype version of it. It's a protocol that defines how a debugger client and server talk to each other. So your editor or your debugger or IDE has to implement the client protocol, and GJS has to act as the server. So if you want to know what this will get us, attend the intern lightning talks on Friday afternoon. So on to the next topic, static analysis, and why I suddenly care so much about it. If you kind of look at the world around us, you'll see that a bunch of things have changed since last GUADEC. One thing in particular, we are all arguing with each other about LLMs. So, things have changed since last year. My workload and my expectations are changing as a maintainer of an open source project. And if you are also a maintainer, I bet yours are too. And like everybody, I'm kind of wondering and scrambling how to handle it. And I do want to acknowledge this is a touchy topic, so I tried to make this section agnostic of whether you think LLMs are great or awful or something in between. So if you're a maintainer, if you get AI slop, obviously you close it. For the record, we haven't yet had any slop in GJS. But as for the rest, there may be useful LLM-generated contributions, and there may be non-useful ones that still have human thought and intention behind them. So you can take the approach of also banning these, or you can review them. If you choose to review them, you kind of need to look at them with a different eye than you used to review contributions. LLMs don't make the same kinds of mistakes as people. The signs are different, and it takes longer to review. So, as a maintainer in the year 2026, I would like to be leaning heavily on static analysis in any repo that I maintain. I want to automate every check that can be automated so that I can spend my time understanding what the merge request actually does. I already didn't want to waste my time telling people well, could you use standard bool instead of gboolean here, or looking out for things like if boolfunc return true, else return false, and that's already tedious to watch for. But now if I also have to tell that to people's chatbots as well, no thanks. So in my case, I already had a whole to-do list of static analysis stuff as nice to have, but I feel the urgency has changed now. But also the tools have improved to the point where it's actually pretty simple to do, and it wasn't in the past. So here's what I came up with. Type-safe wrappers for C++ code, Clang tools, and TypeScript for JavaScript code. You might notice that the obvious candidate GObject linter is missing from this list. I'd really like to use it, but it doesn't work on C++ code. So go and vote thumbs up on issue 63. What's the idea behind a type-safe wrapper? Basically, instead of calling a C function from your C++ code, you call it via a compile time wrapper written in C++, and these wrappers actually end up looking a lot like Rust code if you follow good practices from Rust. I wrote one of these wrappers last year for libgi repository since it's used so extensively in GJS, and here's a sample of what that looks like. So what you can see here is a method wrapper for GI function info invoke. You can see how we use spans instead of C arrays right here. And the spans have the length built in, so we don't need a separate parameter for the length. And we use a helper function, bool gerror, to convert the Boolean return value with the gerror out parameter into a result, or at least a type that works like Rust result, which I think is standard expected in C++. But yeah, that was a lot of work. I spent a large part of the year on it in bits and pieces, and it was surprisingly difficult. So my conclusion is that that kind of thing is maybe not feasible for most of GJS. There is one area where I think I might write another wrapper, and that's logging, because, well, formatting stuff in C++ is a lot easier than in C. And maybe the peel bindings would be useful here. I haven't really looked into that too hard. One surprising thing that I found is that the C++ standard library, at least as of C++ 17, which is the edition that we're using right now, is not up to the job. We don't get standard format and standard span until C++ 20, and standard string view only really becomes more useful in C++ 20. Standard expected only arrives in C++ 23, and standard optional isn't that useful until C++ 23 either. But since we're already linking to Mozilla libraries, some of the Mozilla standard library types can fill in some of those gaps. But in GNOME 52, we will move to C++ 20 when we upgrade the JS engine, because the new engine from Firefox 153 will require C++ 20. There's also two Clang tools that I'm using: Clang Tidy, which is basically a linter, and Clang Static Analyzer, which is a tool that reasons about the data flow through your program using simulated execution or symbolic execution. I've had my eye on these for a long time, but they're actually really good now. If you haven't looked at them for a few years, it's worth another look. They're pretty simple to set up, and I think basically, if you have any C++ code base or even a C code base, you should just set these up. It's you kind of have no excuse not to anymore. The user experience of these tools used to be pretty terrible. You used to have to configure your build to use like a compiler wrapper script instead of your C compiler, and for custom checks, you had to write a Clang plugin and compile it into a shared library and preload it in your compiler invocation. But now you can just drive both tools with one executable. You can check diffs and not only your whole program. And for custom checks, you can just write them directly in your config file. That looks kind of like this. Like here's two checks that I wrote to use like the C++ standard library min and max, which are type safe instead of the C macros. And that just produces output like this, which is really easy to understand. It's like, hey, uh, you used capital Max here, you should use standard Max instead. So if you're reviewing some code and you think, hey, this mistake could be caught automatically, it might just be a question of running clang query to kind of come up with the query expression here, this match conditional operator, blah, 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 and stick that in your config file, and then you're done. So on to static analysis in JavaScript. That primarily means TypeScript at this point. There are other tools, but a lot of people are using TypeScript. I actually want to pause for a moment and rant about the state of static analysis tools in JavaScript. Like in JavaScript, we don't have anything as sophisticated as Clang Static Analyzer or Rust Clippy or whatever, but those tools could exist. I hope the JavaScript ecosystem catches up soon. And a shameless plug, the company I work for, Igalia, has expertise in writing JavaScript build tools. So if you have a particular custom JavaScript build tool or static analysis need, you might be able to hire us. Anyway, TypeScript. I've started using TypeScript pretty extensively over the last year, and I really like it. It forces you to write better JavaScript and not resort to weird tricks. And like at the end of the day, the question is, does it catch bugs? And yes, it catches bugs. It has caught so many bugs already in the GJS code base just from the few experiments I've done with it. But it does have a lot of disadvantages. It transforms your source because it's a transpiler. It takes TypeScript sources and compiles that into JavaScript sources, which are then executed. So it down levels your code to a certain target JavaScript edition, which does not always do what you expect, and there are some pitfalls there. It's also part of the Node.js ecosystem, and Node.js ecosystem tools honestly kind of annoying. You get to pull in a gigabyte of node modules for every tool that you want to use. No thanks. And TypeScript doesn't integrate well with Meson or other make type tools because it expects to have control of your build folder. So like, is there any way we can try to mitigate some of these cons? And I think there is. There's this cool tool called TS blank space. If you use only the additive TypeScript syntax, so no decorators and enums, but just types and modifiers like public, you can run this tool on it and it'll actually replace the TypeScript with spaces and leaves you with plain JavaScript, a bit weirdly formatted. You can see that on the right here. But if you do it like this, you don't even need to bother with source maps because every character of the JavaScript program that is executed is actually in the exact same line and column as the same character in the TypeScript source. So theoretically, you wouldn't need to install Node in order to use TypeScript in GJS. Well, only to actually do the type checking, because what this tool does is it separates the type checking step from the build step. But TS blank space is itself a Node utility using TypeScript's internal parser. So it's still got some of the same problems about downloading a gigabyte of Node modules. Luckily, there are other TypeScript parsers and leaner ones. In fact, there are two. Both of them have a command line utility, and both of them have a Rust API. So SWC stands for Speedy Web Compiler, and that one, in fact, already contains an implementation of TS blank space. For some reason, you can't use the SWC command line utility to drive it. So what I've done is taken the Rust API for it and published a small standalone command line wrapper utility that will fit GJS's TS blank space needs. It's called Redact, see if you can find the pun, and it lives in my personal GitLab space for the time being. On to the type definitions. We need type definitions in order to have type checking. So each GNOME platform library has to have a type definition, like glib, gobject, etc. We have all the information we need to generate these. It's contained in gobject introspection, and we already have a tool which generates them, and that tool is TS for Gur. It's kind of the gold standard. Unfortunately, using it in GJS would bring a circular dependency problem because it depends on GJS. But also this tool has a different focus. The TS4Ger's focus is to give application developers the best possible TypeScript experience in their IDE. So that's a laudable goal, that's as it should be. But for type checking GJS, we actually need only minimal type definitions and we don't need the IDE experience. So I'm working on a small standalone utility built together with GJS and sharing code with it where possible, which is not intended to replace TS4Ger. But in order to make sure that its output is correct, I have been comparing its output to TS4Ger, making sure that they don't diverge except where they need to. And that's been really useful because I've caught a lot of bugs in my own code and also fixed a lot of bugs in TS4Ger. So more on that in a future talk. And then the software freedom considerations. We care about our software freedom in GNOME, and I personally find it concerning that TypeScript is controlled by Microsoft, not by an independent standards body or a foundation or something like that. And there's nothing stopping it from being deprioritized or canceled or enshittified or whatever. But it is completely free software, not open core or anything like that. And there are the competing tools that I mentioned before, SWC and OXC, which provide pressure on Microsoft not to diverge from the needs of the ecosystem. And in the worst case, if we ever wanted to back out of using TypeScript, it would be simple. All we have to do is blank space the TypeScript files and then auto-format them to get rid of the blank spaces, and we have our JavaScript back. There's no vendor lock-in possible. There's other JavaScript runtimes, such as Node, they go a step further, and they automatically strip your types using blank spacing on input before passing the code to the JavaScript engine to execute. So that I'm not sure is the right choice for us, since that brings a bit of a higher degree of lock-in. Once we provide that functionality, it would be difficult to remove without breaking people. But it is a choice. Everything is a trade-off in the end, and I'm going to implement, the trade-off at a certain point on the spectrum. So here's where I'm hoping to land for GNOME 52 or 53. I want to convert all of GJS's internal modules to TypeScript, and then blank space them during the build process. So if you submit a merge request to GJS, you'll be able to write TypeScript code and benefit from having your code checked in CI. Or if you care to install TypeScript locally, you can check it locally in your editor and use the TypeScript language server. For you as a user of GJS, nothing changes, except hopefully you have to deal with fewer bugs in the platform. If you're an app author or an extension author and you're writing your app in plain JavaScript with no transpilation, you can continue doing that. If you're writing your app in TypeScript and using TS4Ger, you can also continue doing that. Although if you like, you could consider replacing your build step with Redacts. Hopefully it might meet your needs if you don't need the whole TypeScript compiler during build time. And so maybe once I've landed that, I'll finally be able to get back to writing my nonograms app in TypeScript. And then about that big hammer, maybe by this time it ought to be known as the big elephant in the room. If you want all the details, you can watch my talk from GUADEC 2019. And that's 7 years ago. My gosh, but I'll give a quick summary. Back in 2018, 2019, we had an issue with the garbage collector in GJS holding on to objects longer than it should have because of the interaction between JavaScript objects and G-objects referencing each other. And this is a problem that actually occurs in lots of runtimes where you combine a language with garbage collection with native code using reference counting. We have a workaround, which is affectionately called the big hammer, that runs the garbage collector every 10 seconds to clean up these objects. This is obviously bad for performance and has been for 7 years, and we've had a fix mostly finished for most of that time. But the problem is that if we merge it, then counterintuitively, GNOME Shell's memory usage will go up again because we are no longer over-collecting garbage. So at this point, before fixing it, there are a bunch of squishy, demotivating problems left to solve, and it's not clear what success exactly looks like. So for the past 6 years, I've been trying to tackle these in my spare time and mostly giving up. So it is therefore my great pleasure to announce that Igalia is funding some time for me and my coworker Tim to work on this problem. Here's what we're going to do. We need to provide more accurate data to the JavaScript engine about how much memory has been mallocked and which JavaScript objects own it, so that it can make better decisions about when a garbage collection is necessary. The branch with the fix got stale, and we need to rebase it. And then we need to actually measure performance and twiddle the knobs of the garbage collector so that we get to some settings which actually provide the best possible experience for GNOME users. And that means finding the right trade-off between memory use and no janky animations because we're doing too frequent collections, and no freezes because we postpone collections for too long and then they take a long time. So to give good heuristics to the garbage collector, we have to solve a 16-year-old issue. We made a bunch of progress on it already, telling the garbage collector, hey, here are a bunch of live objects that own a lot of mallocked memory, so maybe it's worth doing a collection now. We've done this for gbytes, GDK pixbuff, and some Cairo types. Just because of the nature of gobject, we have to do this on a class-by-class basis, so it's going to be kind of an 80-20 situation. But if you have more suggestions for commonly used gobject classes that hold a lot of mallocked memory, let me know. We also need to get insight into the GC performance, and of course the tool of choice is sysprof. Sysprof actually used to have a UI for this, but it was removed in a refactor. And George has kindly made a hacky provisional UI for us, which we've just been downloading the CI artifact from this merge request and installing that as a devel version of sysprof. And it looks like this. And actually, if you look at the malloc bytes row here in the screenshot, like I was recording this while I was taking screenshots. And so you can actually see the mallocked memory in the screenshots, go up whenever you take a screenshot and then go down whenever there's a garbage collection. But anyway, I'd like to land something more permanent in sysprof, and we also need to sort of visually correlate these with the garbage collection timings. So like anytime you're measuring performance, you have to measure what you value. So how do you quantify good GNOME shell and app performance? Anybody got any ideas? Anyway, that's a question I hope we'll be back next GUADEC to answer. So big thank you to everyone who helped in any way with GJS in GNOME 50 and 51. Here's the license for this slide deck, Creative Commons. You can reuse bits as is with attribution and not for commercial use. And I would love to go to questions, but I'm presenting remotely and it's currently 3:30 in the morning where I live. So I unfortunately won't be able to answer questions live, but you can ask them in the GUADEC chat room and I'll answer them in a few hours from now. Thank you very much.